six-sided die, we expect that it's equally likely to land on numbers 1 through 6, right? And that's where classical probability follows through with these problems here. The next is the empirical probability. Right, so again, if you need to slow down the video at any point, pause and then catch up. Here's empirical probability. Other terms for empirical is experimental probability. You'll actually hear that probably more often. And also relative frequency probability. Probably won't hear that as often. The key thing here is that it's based on observation. So some survey or experiment needs to transpire in order for us to say we are using an empirical probability approach. And you can see that there. There's also a formula, but the formula for basic probability calculation is really no different. The notation is different, as shown in the formula, but it's no different than a basic probability question. Right, what you're going to see, since we're not in class right now, is that this hopefully will be some previous data from another class of favorite flavor of ice cream. All right, so you can see that I surveyed 15 students to gather this data, right? And they told me their favorite flavor of ice cream. I just observed something. I gathered some data. Then after gathering this data, which clearly these are not equally likely outcomes, I'm going to answer some probability questions. All right. So the first 3 questions down below are questions that pertain to that experiment that I conducted. I conducted a survey. I can now use my results to answer these probability questions. Look at my probability notation as you read through. Look at my reduced fraction if needed. I also want to point out the other examples on here, because one would think maybe that an example of flipping a coin would always be a classical approach, because in theory, landing on heads is an equally likely chance as landing on tails. However, we could change what would be a classical approach into an empirical or experimental approach by conducting an experiment. So if I flip a coin 100 times and record the number of times that the coin lands on heads and tails, if my experiment ended up where the coin landed on heads 48 times, the probability question would then be based on the results of my experiment. So what's the probability from conducting this experiment that my coin lands on heads? It's 48 over 100, or about 0.48, 48% of the time. All right, here's another one. And this is really an approach of insurance companies. We'll talk about that a lot more in Chapter 5. But kind of identifying the expectation of how long someone may live. Here's a probability given some data in here. In order to get this data within this problem, someone would have had to observe or gather data. So this is an example, again, of an empirical or experimental approach to probability. And you could read through the whole question and see what happened. This is maybe one of the most important things in statistics down at the bottom of the page. It seems like it's hidden in here, but yet it is super important. It's called the law of large numbers. As an experiment is repeated a large number of times, the empirical probability, this experimental probability from the experiment, tends to approach the theoretical probability, or also called the classical probability. So let's think of the coin example. The coin was flipped 100 times up above in number 4. The coin landed on heads 48 times, pretty close to half of the time, as we would expect in classical probability. However, if we were to continue that experiment of flipping a coin, and let's say we flipped it 500 times, it's pretty likely that we're going to get maybe 50%, 250 of those flips land on heads. And that's the idea of the law of large numbers. So there is subjective probability. I'm going to give a quick discussion of. And then I'm going to stop the video there. I would like you to practice the problems underneath subjective probability with identifying the approach, classical, empirical, or subjective, what you think they are. You don't even necessarily have to do the actual probability. We will go over the very last page of the notes in class. Subjective probability is really just an educated guess or estimate. It can be somebody's opinion. It may be based on some type of information, but usually the information is what we would say inexact. It's not very accurate, or there's just no way to get that accurate. Sometimes this happens because there's just not enough data on an event to conduct an experiment to gather that. Some subjective probability is even the way the stock market works. They are using, information to make predictions about how the stock market is going to play out, but it's really just, an educated guess or estimate. So with that said, you should practice the next set of problems on the remaining part of this page in trying to determine, based on what we learned in these notes, which approach is happening. Beyond that, you can bring these notes back to class and we'll finish them off.